All right, so this is the lesson on growth and decay. So exponential growth, but for this lesson, the part that's missing that we're going to solve for is going to be in the exponent. We're going to set up an exponential equation, and we're going to solve this exponential equation using logarithms and then our calculator. All right, here we go. Mark started a new blog to write about his travels. Initial week, he had 800 readers. From this point on, the number of readers each week increased by 25%. So I'm going to circle the essential information. Use an exponential growth model. So it tells you what model to use. Find the week in which the number of visitors reaches 10,000 people. So the model we're using is an exponential growth model. This is what it looks like. It's A times 1 plus R to the exponent t. A is the initial amount that we're going to plug in. So the initial amount of readers he has is 800. The growth is 25%, but I'm going to write it as a decimal. So R is 0.25. I actually don't know the time. That's what I'm looking for, right? So find, from this point on, the number, find the week. So that what I'm looking for is the time. And then 10,000 people is the end amount. So F of t in this situation represents the end. So 10,000 is the end amount. This situation is how long would it take to go from 800 to 10,000? All right, let's solve this equation. So we set it up. We're a good reader. We plug in the information. Now solve for t. So divide by 800. So if I reduce this down, that'd be 100 over 8. That's good enough for me. 1 plus 0.25 is 1.25. So now we have an exponential equation. We've isolated the exponential part. At this part, to solve for the exponent, we need to write it as a logarithm. So to write this as a logarithm, the exponent is t. The logarithm has a base of 1.25. And inside the logarithm is 100 divided by 8. So that's what we're going to type into our calculator. So let me see if I can show you that. There's my class, taking attendance. Here's Desmos. So in Desmos, you would type log 100 divided by 8, move the cursor, and then divided by log 1.25. That's it. So that will give you the answer. That's 11.319. And then we're going to write a nice simple sentence at the end. And so the question was, during which week? Find the week. So during week 12, we're going to round. The number of visitors reached 10,000. All right. A new stock entered the stock market in January 2012. The initial price was 72 cents. 4 years later, the price was $3.85. Using a continuous exponential growth model. So there's a good start. This is a continuous. Here, I'll write it this way. There is a continuous growth model where E is a number. So it's P times E to the exponent RT. In this example, P represents the initial price of the stock, which is 72 cents. F of T again represents the end price of the stock, $3.85. The exponent R, the rate, I don't know. That's what I'm looking for. But we know how many years have gone by. T is equal to 4. So that's the equation we're going to solve. To solve this, we're going to divide by 0.72. I'm not going to simplify that down. So it's $3.85 divided by 0.72. That's e to the exponent 4r. So if we multiply it together, it's 4r. Now, to solve an exponential equation like this, we're going to write it as a logarithm to solve it and put it in our calculator. So to write this exponentially, the exponent is 4r. The logarithm that has a base of e is ln, and then inside that is 385 divided by 0.72. And then the last step to get r by itself is to divide by 4. All right, go back to our calculator. So again, that's ln. And inside the ln is 385 divided by 0.72. Move the cursor, divided by 4. Now that's going to give you a rate. That's why it's a decimal answer like that. So we're going to write down the rate I see, which is 0.419. And then when I write my answer, I'm going to change it to a decimal. So there's my answer. So now we're going to write a good sentence. The question was, all right, so 4 years later, there was a using a find the growth rate. So the growth rate is, as move the decimal 2 to the right, it's 41.9%. That's an amazing growth rate for money. So the growth rate is 41.9% over 4 years. Great return on investment, ROI. Here we go. A certain medicine has a half-life of 5 hours, and so half-life will give me the model. So let me give you the model of half-life. And in this situation, it's every 5 hours, so it's t divided by 5. Oh, and I need an a in front there to represent the initial amount. So there's the model for half-life. Initially, the patient's given 500 milligrams. Half-life means the rate is 0.5. That's what half means, 0.5. And I'm solving for t. And then how much time will there be before it then is 100 milligrams? So understand the model and then understand to be a good reader and substitute in. I'm going to solve for t. I'm going to divide by 500. That's 1/5, a little bit easier to write down. 1 subtract 0.5 is just 0.5. And then the exponent is t over 5. I need to write this as a logarithm. So the exponent, t over 5, the logarithm has a base of 0.5, and then inside the logarithm is 1/5. Multiply both sides by 5, and then put that in your calculator. Okay. So let's type that in. So I'm going to start with 5 times. I got to move my face. All right, 5 times. And then I'm going to type in a log 1/5 divided by, oops, not yet. Sorry, move the cursor. Divided by log, and it's 0.5. Move the cursor. No, that's it. And that's it. Times 5. Perfect. There it is. So it's 11.6. We can round to that. So we just found the hours it would take to go down to 100 milligrams. And the hours it would take is 11.6. The question is, we started at noon. How much time will they have, right? What time will it happen? So at what time? So 11 hours later would be 11 p.m. But 0.6, how many minutes is that? So I'm going to go 0.6 times 60. 0.6 of an hour. So 0.6 times 60. I can go 6 times 6. So I understand that that answer there is 36 minutes. 6 times 6. So if I put it together, At what time? So at 11:36 p.m., right? There will be 100 milligrams remaining in the bloodstream. So at 11:36 p.m., there will be 100 milligrams remaining in the bloodstream. All right, number 4. The growth of a plant can be modeled by the equation below, where h is the height of the plant and t is the number of weeks since the seed was planted. How many weeks will it take for the plant to be 50 centimeters high? So the answer to that is, we are already given the model, so we don't have to have and pull that out. So we're given the model, plug in 50 for the height, and then we have to solve for the variable. So do you have the algebra skills to solve for t? So let's try this and to see if we can solve for t together. So step 1, the inverse of dividing, we're going to multiply both sides by 1 plus 12 times e to the negative 72t. Again, our whole goal is to get t by itself. The next step is we're going to divide by 50. And it goes in evenly 5 times. Next step, we're going to subtract 1. That's 4. Then we're going to divide by 12. So 4 divided by 12 is a third. And then the next step, once we have the exponential isolated, we're going to write it as a logarithm. So the exponent is negative 0.72t. The logarithm with the base of e is ln, and then what goes inside is 1/3. So that means the last step here is to divide by negative 0.72, and then use your calculator. All right, let's do that. So again, we're going to go ln 1/3. Move the cursor, divided by negative 0.72, and I get 1.526. So I'll come back here, write a simple sentence, and then it's over. So I got the time to be 1.526. So how many weeks will it take? It will take, I'll round, it will take about 2 weeks for the plant to be a height of 50 centimeters. So it'll take about 2 weeks for the plant to be a height of 50 centimeters. All right, turn the page. Number 5. A small lake is stocked with a certain fish. The fish population is modeled by the equation below. P is the number of fish in thousands, and T is the number of years since the lake was stocked. How many years will it take the fish to reach 6,000? So because it's in thousands, 6,000 really means that the population is 6 because it's in thousands. So we're going to write down 6 equals 8 over 1 plus 3 times e to the negative 0.7t. So there's your start. Now I need to have the algebra skill to solve for t. So step 1, the inverse of dividing, is to multiply both sides. So I'm going to do that. So multiply both sides by the denominator. The next step, we're going to divide both sides by 6. 8 divided by 6 is the same as 4/3. I'm going to subtract 1. So when I subtract 1, 3 over 3 is subtracting 1, so that's a third. And then the next step, I'm going to divide by 3. So when I divide by 3, 1/3 divided by 3, 3 times 3, that's going to give me 1/9. So e to the negative 0.72 over 1/9. Then to solve this, we need to write it exponentially. So the exponent is negative 0.7t. The logarithm with the base of e is ln, and then inside is 1/9. And then divide by negative 0.7. So ln 1/9 divided by negative 0.7. Oops, I didn't mean to hit that one. This is the one I wanted. So ln 1/9 divided by, oops, move the cursor, divided by negative 0.7, and you have your answer. So it's 3.139. So the question again was, so it's 3.139. How long will it take for that? So the answer to that is it will take about 3 years for the fish population to reach 6,000. Done. All right, number 6. If $500 is deposited into a retirement account that pays an annual interest rate of 4%, compounded quarterly, how long will it take the account to reach a balance of $1,200 if there are no other deposits or withdrawals? Break it down. So $500 is the initial amount. 4% is the rate, compounded quarterly. So I need a model for compounding quarterly. And so this is the model for compounded quarterly. And then we're going to fill in with this model. So the initial amount was $500. The end amount in the account was $1,200. The interest rate was 4%. I need to write that rate as a decimal, so it's 0.04. Quarterly means 4 times a year. And then I'm solving for t. So there's the model and there's the setup. Divide by 500. So when you divide by 500 and reduce it, that's 12 over 5. Now, if I use a calculator, 1 plus 0.04 divided by 4, I'm telling you right now, that's 1.01. So just type that in a calculator, you would get 1.01 to the 4t. And now I need to write that as a logarithm. So the exponent is 4t. The logarithm has a base of 1.01. Inside the logarithm is 12 over 5. Divided by 4. Type this in your calculator to get your answer. So it would be log 12 over 5. What do we got again? Divided by log 1.01, and then divide that by 4. Oh, what happened? So log 12 over 5 divided by that. That's good. How about here? Now divide it. I got to move the cursor. Now divide it by 4. That's better. I just had to move the cursor first. 21.999996. All right, let's write a simple sentence. How long will it take? It will take about 22 years. All right, for the account to reach $1,200. Number 7, Dave deposited $500 in a savings account. After 15 years, the account had tripled with no other deposits. Assuming the interest compounds continuously, there's my model. So if it compounds continuously, this is the model I'm going to use. The initial amount was $500. If it triples, if you triple 500, it is 1,500. The interest rate is what I'm looking for, and 15 years is the time. So you substitute in the essential information, 500, 15, tripled, gives me the end amount. Now solve for the interest rate. So divide by 500. So tripling, so that number is going to be 3. R times 15 is 15R. Write this as a logarithm. So the exponent is 15R. The logarithm with the base of e is ln, and then what goes inside is 3. Divide by 15, and you have your answer. So ln 3 divided by 15. Super simple. And the interest rate would be 0.0732. Move the decimal 2 to the right. We'll round. So there, if you move it 2 to the right, the interest rate was 7.3%, moving the decimal 2 to the right. All right, last one for the lesson. Scarlett invested $8,000 in an account, pays 7.5% interest per year, compounded continuously. So that gives me the model I'm starting with. The initial amount is $8,000. The interest rate, as a decimal, is 0.075. How long will it take? So T is what I'm looking for. The account to reach 10,000. And there's my setup. And now I'm going to solve for T. So divide by 8,000. I'm going to reduce it down to 10 over 8. I could reduce it down further, but 10 over 8, it makes me happy. E to the exponent 0.075t. The exponential is now isolated. Write it as a logarithm. The exponent is 0.05t. The logarithm with the base of e is ln. And then inside is 10 over 8. The last step is to divide by 0.075. And now use your calculator. So ln 10 over 8. Move the cursor. Divide that by 0.075. And it'll be about 3 years. So 2.975. All right, write a simple sentence and you're done. So it would take about 3 years to reach $10,000. That's it. Mr. G Math, over and out. Till next time.